there will be different kind of losses. Here, so one kind of force is present, you know, which has a negative impact, dissipative effects. That is frictional force. Here, the energy is lost. So if there is a system, within the system or outside the system, if there is a presence of this kind of forces, definitely there will be some energy losses. And initial total energy should not be equal to final total energy. Okay? But if we consider such kind of forces, it is important conservative force. Conservative force. Example, gravitational force is a conservative force. Gravitational force. Why? What is meant by conservative force? Suppose this plate is here. Okay, it has certain mass. Now I have lifted the plane up to this level. So with reference to this data, it has some now elevation height. So it has gained some energy. That energy is called as potential energy. How much potential energy? How much force I have applied, and that is this much the distance. Here, now if suppose I take this mass here to suppose here, then here, and finally here, then what will be the potential energy? Here, because it is the one of the initial position and one is the final position. I remains same. Whether I take the same height in different path, that does not matter. Here, that's why it is called conservative force. Because ultimately you need the same displacement, same amount of potential energy gained on this piece. So when such kind of forces are present, that is conservative type of forces. One simple example is the gravitational force. Because you can see here whether it is shifted here, that here finally, and it will be directly same here. So in that case, that work done, that should be equal to the difference in the potential energies. Initial potential energy minus final potential energy. So if we combine now the previous work energy principle, then it will be equal to change in this final kinetic energy minus initial kinetic energy. Here, so finally, if we see, so summation of all energies initially will be equal to summation of all energies final. Represents final, one represents initial. Definitely there should not be any dissipating force like friction. Otherwise, there will be an extra term added here, energy lost due to friction. Here, energy lost due to friction. Here we are considering it to 0. And exactly this will go. So if unless and until you do friction, then you can apply this one, which is nothing but another version of work energy principle. Clear? So in that case, total energy initial should be equal to total energy. Right? So the same problem you can solve, already told earlier, that if the problem involves the data with force and acceleration, you can directly go for DL1. When the problem involves with force, displacement and velocity, you can go for work energy or here. So this much the theory is very simple, but you have to apply it correctly, because in different form you have to find out the expression of this potential and current. That one only you have to find out correctly. Here, when it is 0, when which one is 0, which one not 0, that you have to understand after reading the questions. If Write down the one question. A 25 kg collar. A 25 kg collar. C-O-L-L-A-R. 25 kg collar slides without friction. So it is proved already in the problem without friction. Slides without friction along a vertical rod. Along a vertical rod. The spring attached to the collar. The spring attached to the collar has undeformed length. Undeformed means neither stretched nor its complex. Has undeformed length 200 mm. Has undeformed length 200 mm and a constant of 1000 Newton per meter. 1000 Newton per meter. That is speed constant. 1000 Newton per meter. So what is Newton per meter? What can you understand? 1000 Newton per meter means speed constant. So if you apply on the spring 1000 Newton tensile force, it will be stretched by 1 meter. Here, if you are applying 1000 Newton compressive force, then it will be compressed by 1 meter. Here, so here directly is given in Newton per meter. Stop. If the collar is released, if the collar is released from rest, determine the velocity when it has slided down 200 mm. When it has slided down 200 mm. So that is, this is collar. Suppose this is the collar and it is attached to the spring. Here it is fixed, right? So here is a vertical rod. This is the vertical rod, and once the system was at rest, now once we release this collar or slider, it will start to move down. Here, so the question is asked, how much will be, initially it was at rest, how much will be the velocity of this collar or this slider or this rod? When it has moved down, how much? 200. Finally, suppose the collar is here. Here is the collar. So it has moved down by 200. So definitely that time it will have some velocity, and at the same time the speed will be direction or compression? Direction. Spring is straight here, and the length of the spring undeformed. Natural length. How much given? That is also given 200. That is also given 200. So using principle of conservation of energy, also using continuous distribution, find out how much will be the velocity of the block here when it is moving down. So what you have to consider? write down this general and applying what given principle of conservation of energy. Then you write down this equation. You write down initial here I, here A also final. And after that you go on writing down the expression separately so that the examiner can put some part marks. So the way of writing is answering is that you should write down first the expression. What is the expression of potential energy? Then what is the expression of kinetic energy? Then their potential energy final. So this way you should answer. So just fill up potential energy. So whenever you are going to calculate potential energy, you have to consider a reference level where potential energy is 0. Suppose this flow. Here inside this classroom we are considering here potential energy is 0. So if someone here is that much is the potential. Here but this is not underground level. For this classroom this is the ground. Clear? Again if you go on taking the arc, then it has this lower level of potential. So it is important you should consider the reference level correctly. So let us consider that this level since it is 1, so this is the reference level or it is also called data. The reference data potential. So this is the so data means what does it mean? That here we are considering potential energy 0. Clear? So how much is the potential energy at state 1? So this is right. Half more elaborately we write V1 square plus now there is a spring. So whenever spring will be stretched or compressed, you have also some potential energy, the state energy. So this study told half k delta square. Sorry. And so potential energy mgh. So mgh plus now spring energy half k delta, that was the maximum value. So deflation half k x square x is the deflation. Here elongation positive with compression negative. So half k square. Now for level 1 that delta is h is 0. Now x is also 0. Elongation positive, compression negative. That is the starting formula. So usually reference height is plus, length is minus. Clear? Because measurement you have to take considering the side. Another nothing but is survival. Clear? So if you consider ceiling as the reference, you may consider that time it will be dead. Clear? So like that only. So here for the ceiling. Clear? So this is your considered that. Final potential energy at level what or initially it is given. Now kinetic energy R m v1 square. It is clearly stated starting from a system which is stored is D is 0. Now come to this. Now you have to write correctly the expression of this, which will not be there. Follow potential energy at this location. Final. Not final. It will continuously slide down to its maximum extent. Okay. So here potential energy will be how much? Mass m g h will be how much? Here, so mg, you write first mgh. When you are writing, you write here 25 kg into 9.81 meter per second square. Here to get more part mass. To get more part mass, you write here 25 kg into 9.81 meter per second square. So you are providing the scope physics part. Here, if you are not strong enough, it is very difficult to get in every individual day over. Keep space to keep your part mass. So along with that, better if you write also the unit. So 25 kg, here 9.81 meter per second square into h. So minus 0.2. What will be the unit? H into meter per second square into meter. What is the unit? आपने से ऐसा क्वेश्चन है सामने हमने लोग joule, right? So this was joule. So you calculate. So this is mgh, not only mgh. Half last half a square, because here this length is no more 200 mm. This length is no more 200 mm. How much? How much? Calculate the length of this. Suppose this is 4 this length is how much? So this is Pythagoras theorem, you can easily find it. Right? It's a right angle triangle. O1 2. So this one square plus this one square under root. Equal to this hypotenuse length. So this is 2 into 0.2. This is meter 0.2. 0.2 means 0.2 square how much? 0.2 square how much? 0.2 square is 40 rupees. So they are also 60% student will do this calculator. Competitive exam, such kind of simple calculations, no much of calculator is allowed. Simple calculation this way you have to do it. When there is a part of manual calculation in the case, that means there are also for calculation purpose marks is provided. Yeah, but in the university exam, since it is not calculator is allowed, yes, there is calculator. So that's why you are going to get, if you know how to use correctly because when you are purchasing calculator that is also manual. So many things you can do in the other. It's not only the same thing other people are doing. Okay. So that will be the length. So how much is coming? 0.28. So half a square plus half. How much is the 3%? It's remaining ऐसा ही 1000. How much is x? Denomination is how much? This is original length, this is the stretched length. So how much is elongation? 0.28 minus original length. So if you lose your concentration, then and there, done. Clear? Wastage of 2 pages in the answer script. Wastage of 15 minutes to half an hour. Clear? So 0.08 meter. Yes. So this will be the expression for final potential here, and what will be the expression for final kinetic energy? Half mass is 25 into this. Now we will apply to this. Initial total energy how much? Initial total energy is 0. So initial total energy that you apply to this 0 is equal to the meter capacity. Then how much is coming? This potential energy. Just find out the answer now. Potential energy into it has certain values plus half m square. So you are going to get the V. So use calculator and get the value. So here when calculator is not allowed, that time you are supposed to consider 9 to 10 sometimes. Yeah. If calculator is allowed, you should consider the exact value. Suppose pi. Pi. How much is pi? 22/7. If you know calculation, if you consider 22/7, 3.14 cancel out. If you consider 22/7, any type of competitive exam test, you will see so many things will be considered. Pi will not create any problem. You have to consider only 22/7. Pi is not equal to 3.1. Yeah, 3.1 to so 22/7. If you are using calculator, in the calculator button there is exactly 5 stored. So you should press that button and 5 is written in the calculator. There, because if you multiply in place of 5 with 3.14, there will be error. These errors are not good when you are doing the experiment in the lab. The experiment calculations in decimal, if answer deviates, then there will be problem. You should be making at least up to 3rd decimal or 4th decimal. Is correct. Calculation for just put 25 into 9.81 into 5. Put that product minus sign plus half. Potential energy how much? Minus 45.85 joules. Kinetic energy is. So finally what you are getting then? 0 is equal to left hand side initial total energy was 0 is equal to minus 45.85 plus half into 25 this one. Now find out P. From here can you find out here? particle. Answer also 1.9 meter per second. Velocity will be 1.9 meter per second. After calculation, you can verify later that answer will be 1.9 meter per second. Answer 1.9 meter per second minus 45.85 plus half meter per square is the resolution. Now you are told, so they only will be confident that you can be able to solve the numericals at the exam hall. You have got out here is the data. Reference here. So here potential energy 0. And after that, those expression will be changed. Clear or not? Solve. Same as in the 1.9. Then that is called practice. That is called practice. You have seen Indian cricket team in practice what they play. Other than cricket, all other sports they play, including swimming. So, if you want to study, then you have to also consider what is part of that. I will consider this. So, according to this all, same answer. Now, try this problem yourself. A ball of mass m. A ball of mass m is dropped. A ball of mass m is dropped onto a spring of stiffness K. Otherwise, only we have to do the notation. The ball of mass m is dropped onto a spring of stiffness K from a height small h. From a height h. From a height h. Okay, find out the expression of deflection of the spring. Find out the expression of the deflection of the spring. If the ball is brought to rest. If the ball is brought to rest. Have you understood? So those variables are mentioned. So you have to find out the expression. Final answer is A, H. This is given. So here is a spring. Here is a spring. Okay. So here is a spring. Here is a rotor. This height is given. H. It will be dropped. Dropping is not same like throwing. When you are throwing something, you have to keep some initial velocity. Dropping means just release. Projectile initial project how will be drop unless and until. But this is not the case. So what is the drop? The initial velocity of the ball is 0. It is dropped from a height h to the spring. Then what will happen? They will remain contact. Okay, equal to, you have to find MAH. How delta deflection of the spring is related with mass, stiffness and here. So that deflection is depends on how many factors? Three factors. Here. So if suppose this is not related to the numerical, now I am asking to delta depends on these factors. Now suppose if you want to find out what is the relation between delta and mass, then what how will one consider? Three factors. Delta here you will see that where we will going to find out next question there will be presence of mass. Here now you want only to find out how this delta is going to be affected due to the change of mass. How to find out? Or suppose you want to find out what is the effect of delta only into K stiffness. Delta normally depends on all three: mass, stiffness, and the height. Now you are only interested that how delta is going to be affected only into the change in stiffness. You are not interested about how much is mass, how much is height. Only the relation between delta or delta mass. So then what you have to do? Suppose you want to find out the relation between delta and M. So delta you want to find out as a function of suppose K, stiffness, factor K. Okay? So what you have to do? You have to keep these two fix for the result. Here, then also you are going to do the experiment related to this that function not G. So maybe if G is not that acceleration due to that G. Suppose this is function F1. Okay? So where you can see any quantity depends on multiple factors. If you want to find out, then you have to go for other factors keeping constant. Then you find the ठीक है जी finally. So now you how to solve this. because this delta, you see when the ball will strike the spring, it will come toward this direction. So the movement of the system downward, negative, downward, upward you are considering positive, that's why you are considering downward negative. Upward if you write here minus HGN, then upward you are considering negative, downward is considered positive. Same to the word now. When you are measuring the position of each ball with reference to this data, so this is your starting measurement from this point toward this. When you are measuring the direction, you are starting from this point toward this. So the direction is completely opposite. Whatever sign convention you are considering as positive, anything opposite to that nature is negative. Clear or not? So usually we consider upward that is positive. Clear? So if upward positive, potential energy how much? At step 1, mgh plus kinetic energy half m is just released. Kinetic energy was 0. This is equal to, now we have to here kinetic energy final how much? It's clearly stated, deflection maximum system comes to rest. Kinetic energy is 0. As per this problem statement, only potential energy expression you have to write directly. So what will be the expression of potential energy? It has a mass m, spring has negligible mass. It has a mass m. So how can mgh you have considered this as positive? So it has gone. We have not anything you are considering. Suppose when a miner going inside the mines under the earth, potential energy becomes this is not local. Negative होगा तो but you are you are considering ground level as 0. So anything here positive. So anything inside the negative. Okay. So it is minus h हो गया delta. That comes out ruling पे everything is. That is the problem with the subject. That is minus mg delta. Here plus so the expression becomes half k delta square minus mg delta plus mgh is equal to 0. So this is a what is this? Quadratic equation in terms of unknown delta. So what will be the expression of delta? Kalki to bolechi. So delta is equal to minus this is b minus b. So mg plus minus b square. B square means minus mg square minus 4 half k. See? এটা এদিকে চলে এলো তো mg এদিকে নেগেটিভ হবে নেগেটিভ হবে আলটিমেটলি প্লাস হয়ে যাবে why 2 means 20 half k delta তাহলে কি হবে ফাইনালি mg plus minus এটা mg square minus minus এখানে প্লাস so put over mg square plus 2k mg h by k. This is your expression. This is your expression. check verify input of suppose